what we're going to learn now is that 4-Life transfer factor is comprised of cow colostrum and chicken egg yolk. We're also going to learn that 4-Life transfer factor is made by the immune system for the immune system. And specifically, transfer factor is made by the immune system of cows and chickens, and that immune system, as Dr. Vaughn talked about, can be transferred to other mammals, other species. Okay? We're also going to learn about how 4-Life utilizes very special filtration procedures to extract out transfer factors from cow colostrum. Okay? And then we're also going to learn how 4-Life better understands transfer factor through characterizations using several tools like amino acid composition, size extrusion chromatography, and proteomics. Okay? Are we with me? All right. So let's first define and describe the source of transfer factor. Well, I just said it comes from what? Where does it come from? Cows and chickens, right? And colostrum comes from cows, is the first milk by the mother to the baby calf. Okay? And it's done in the late stage of pregnancy and then in post-lactation. And it's yellow in color. It's not white like milk, right? It's yellow in color. And it's important to point out here that when 4-Life gets its transfer factor, it only takes a small portion. Most of the colostrum that the cow produces for the calf is given back to the calf, because calves need to have that colostrum in order to help their immune system mature. Okay? Does that make sense? Okay. Now that colostrum comes out in the first 12 to 16 hours, and it provides us a rich source of transfer factor. Okay? Now the egg yolk's a little bit different. It's the nutrient-rich portion. The egg yolk is the nutrient-rich portion of the egg, and its primary function is to provide food, sustenance for the embryo. And that's coming from chickens. And now, let's look at how transfer factors are made. So the ability of mothers to transfer immunity to their offspring has been well documented for a century, hundreds and hundreds of years. And that's in mammals as well as birds. But for mammals, that takes place either through the placenta or through colostrum. For birds, reptiles, and fish, that transfer process actually happens through the egg. Okay, so it's a little bit different. And what it does is it transfers these immune-benefiting ingredients, which are important for the offspring's survival. Because remember, the offspring, the baby, their immune systems are immature and naive, and they haven't been exposed to all the health threats, right? And so they need that knowledge that the mother already has with these existing health threats. Okay? Okay, now that we understand the purpose of transfer factor, let's look at kind of the composition of these transfer factor sources. So bovine colostrum is a complex mixture of fats, carbohydrates, proteins, growth factors, enzymes, enzyme inhibitors, nucleotides, cytokines, fats, vitamins, and minerals. You got that? That's going to be on the quiz at the end, okay? Now, the point is that colostrum's highly complex. Very, very complex mixtures, complex samples. And so for us to get transfer factor out of that, and for us to study transfer factor, you have to use highly sophisticated equipment, highly sophisticated filtration procedures, because it's a very complex mixture. Okay? And we have all that because we want to make sure that we have peak production of transfer factor, fresh, rich, bioactive sources of transfer factor. Now, egg yolks make up about a third of the weight of the egg, and it provides a rich source of macronutrients such as fat, carbohydrates, and proteins. And it really is to give sustenance to the chick. It also functions as a good source of vitamins and minerals. Okay? All right, so we can utilize our knowledge of these immune-benefiting ingredients and advanced testing methods to be able to monitor these as they pertain to the mother's passage of the immune system to the offspring. The majority of these immune-benefiting substances are called immunoglobulins. And Dr. Brock's going to talk a little bit about the immunoglobulins when she gets up there and talks about how transfer factor works. And for colostrum, there's an immunoglobulin called IgG, and it makes up about 80% of the proteins out in colostrum. For egg, there's an immunoglobulin called IgY, which is coming from the egg yolk. Now we can observe the transfer of these immune knowledge, these immune benefiting ingredients from the mother to the offspring by following IgY and IgG. Okay? And this information allows us to optimize, to make sure that when we get transfer factor out of the egg yolk or out of the colostrum, that we're getting the freshest, richest source of transfer factor. Okay? Does that make sense? And we can do that at the farm level, right? We can monitor these processes by each farm where we get colostrums. Okay? All right, so as you might have learned, as we just mentioned, that transfer factors are small peptides and proteins, and they're used to educate the immature immune system of the newborns to be able to recognize. Now, you guys should know this part, right? So let's say it all together. Recognize, respond, and remember, right? Recognize, respond, and remember. Now, these proteins and peptides are made up of large molecules and small molecules. And the immunoglobulins, by comparison, are very, very large, right? Dr. Vaughn, we talked a little bit about the size. Calvin came up here and scared everybody. Transfer factors are small, immunoglobulins are large. And so the process to obtain transfer factor out of colostrum, right? Colostrum is highly complex. And so we need really special procedures to obtain those. That involves several steps. It involves defatting the colostrum, right? There's fat in colostrum. It involves pasteurization. We want to get rid of all these environmental threats that might be in the colostrum. It also involves concentration through these very fine filters. And that's really the key here, is that concentration step. Because we want to take these small molecules, these small peptides and proteins, and extract them out of colostrum so that we can have this fresh, rich source of transfer factor. Okay? And then after that, we go from a liquid state, right? Because this is all liquid, and then we spray dry it into a powder. And the powder we can put into capsules, right? Into our products. Okay? Does that make sense? Now, what's really cool about this part is that this is a very cutting edge, very sophisticated way to get transfer factors out of colostrum. In fact, it's so cutting edge, it's so sophisticated that we have patents around how we do that. And do you know what that does for us when we have patents around that? It protects our formulas, it protects our process, it protects our way to get transfer factor so that nobody else can do it. Right? Yeah. And how does that help us? It helps us create exclusive products that nobody else can make. And so when you go out and you sell transfer factor, and you talk about transfer factor, you talk about the story, you can talk about this and you can be proud of it because nobody else has it, right? It allows us to differentiate ourselves from everybody else because nobody has transfer factor like 4Life, right? Okay. Now, getting transfer factor out of egg is a little bit different. It's a slightly different process. And in the simplest terms, we get transfer factor by what we call phase separation. And this is, in simplest terms, this is just taking the egg yolk from the egg white and the shell and carrying along all these immune benefiting ingredients through the egg yolk. And so that's how we get it from chicken egg yolk. Okay, now let's shift gears a little bit and let's talk about how we study it, how we characterize it. Because that's really important for customers and distributors alike so that you get the most bioactive forms of transfer factor, right? These immune benefiting powerhouses. And we call this area of science transferceutical science. And really what that means is that it's the characterization, the exploration of the activity of transfer factor. Okay? And in part 4 of this series, Dr. Brock is going to talk a lot about the activity of transfer factor. How does it work? How do we show that it works? Okay? And we do this in 3 different ways, the characterization part. We do this within regards to the composition of transfer factor, the size of transfer factor, and the identity, right? The identity of transfer factor is really important. We've been doing a lot of work on that. And we use 3 different types of techniques. We use amino acid analysis. That gives us composition. We'll talk about that in a second, right? Does everybody know what amino acids are? Okay, building blocks, right? Think about it, building blocks of peptides and proteins are amino acids. And so we do amino acid analysis to find the building blocks of transfer factor. We also have size exclusion chromatography, and that gives us information on the size, right? We talked about the size. And then we have this new area of emerging research called proteomics. And that really helps us identify what transfer factor is. Okay? All right, so let's go through each one of these. So amino acid analysis is utilized to determine the composition of transfer factor, right? And so we do that. The process is that you take these peptides and proteins, you break them apart in very specific spots, and that releases amino acids. And then you can take these amino acids, these liberated amino acids, and you can use chromatography to separate them, to detect them, and to quantify them. And that gives us information on the composition of transfer factor. And so you can look at these graphs and you can see that the composition of transfer factor from colostrum and from egg, right? We have ovofactor, ultrafactor, and nanofactor, and the composition is very similar. Now, interestingly, these amino acids some of these amino acids are called essential amino acids, and they're ones that our bodies can't make. We have to acquire them through the diet. And it's interesting and it's important to know that we have 9 of these in transfer factor, right? So you're getting essential amino acids when you take transfer factor. Did you ever think about that? I mean, when you think about amino acids, usually you're talking about whey proteins and that sort of stuff, but it's the same concept with transfer factor, right? We have amino acids, you're getting essential amino acids from transfer factors, okay? All right, now let's switch on and go to size exclusion chromatography. So amino acids give us information on composition, but what about size? What about molecular weight, right? Dr. Vaughn talked a lot about the size of transfer factors. Well, you will recall that we extract transfer factor out of colostrum, out of egg, right? And there's all kinds of immune benefiting ingredients in there, and they're all different sizes. And so we want to be able to study transfer factors, which are the smaller ones, right? And so we utilize this technology called size exclusion chromatography to monitor this process. So this is a chromatographic method in which biomolecules in complex solutions are separated and analyzed according to their size, right? We can separate out these complex samples and then study them based on their size. And in the case of ultrafactor, nanofactor, and ovofactor, we look at that in terms of 10 kilodaltons and 5 kilodaltons, okay? So, colostrum and egg yolk contain many different proteins, right? Very complex, and they're varying in significance, right? We have the immunoglobulins, which are the larger molecules, and then we have the transfer factors, which are the smaller molecules. The immunoglobulins are usually over 20,000 kilodaltons, whereas transfer factors are less than 10 kilodaltons. So we can look at these graphs here, and we can see 2 graphs, right? These graphs are called spectra. And on the top spectra, that's what a size exclusion chromatography experiment looks like when you look at colostrum. And you see these peaks and these valleys, kind of like these mountains. Those are the large, on the upper graph, those are the large immunoglobulins, right, that make up the protein content in colostrum. And if you go to your right a little bit, I'm gonna see if I can use my pointer here. If you go right over here, right, that part there, you see a little bump, right? For those of you over here, we have a little bump right there, right? That's transfer factor. Not very much, right? And so we need these really sophisticated extraction techniques to be able to pull that transfer factor out of colostrum. And so when we do that, when we utilize these techniques, this is what we get down here. See how the immunoglobulins are gone now? The large molecules are gone, and now we're left with the small molecules. And this is their filtered colostrum. So this is the ultrafiltrate. This is the ultrafactor. Okay? Does that make sense? Does everybody see that? Does everybody understand? So size exclusion allows us to interrogate the size of these molecules. Okay? Now, why is that important? Well, again, we want to be able to understand these at a molecular level. We want to be able to understand that we are getting the best transfer factor out of our colostrum. And this is one technique that we use to do that. Okay? Has everybody got that? Okay. So now we know a little bit about the composition. We know a little bit about the size. What about the identity? what is these transfer factors, right? What's their identity at a molecular level? What are they? And we use a technique to do that called proteomics. And it's similar to size exclusion in the sense that we are separating out these very difficult components in colostrum, and then we can get what we call a chemical fingerprint. Because when we detect it, so we've separated them, and then when we detect them, we can get a chemical fingerprint, a biomolecule fingerprint. And that essentially is a way for us to identify what these transfer factors are, if we know them, right? You kind of have to, with any fingerprint, you have to know who the person is. If you don't know who the person is with the fingerprint, you may not be able to identify it. And it's the same concept here. And then we can identify these by taking that fingerprint, putting it into a large database of known peptides and proteins to help identify the transfer factor. Does that make sense? Okay, so this is an identification technique. All right, now, this is really highly technical stuff. Very, very sophisticated instrumentation. And so for us to do this, we have to work with a lot of different universities to be able to interrogate transfer factor at the molecular level. And so we work with University of Utah, we've worked with Northwestern University, we've worked with University of Minnesota. We're just getting ready to work with the mass spec facility at the University of Colorado, because they have this sophisticated instrumentation to be able to study and identify these small bioactive peptides. And they also can provide clarity for what some of the unknown peptides are. Okay? All right. Oh no. Oh great.
Come on, man, sit down.
All right. Okay. Everybody calm down. It's okay. All right. All right. Okay. Ladies and gentlemen, Calvin Jolly, VP of Corporate.
Listen! Dr. Vollmer, first of all, you're stealing my look. All I got is this. You got a PhD. Don't steal this from me. Now, every time Dr. Vollmer says, "Do you get it?" I'm like, "No, I don't get it." And every time Dr. Vollmer says, "Is it simple enough?" in the simplest terms, and then it's very confusing to me. Proteomics, this, that, and the other. Will you please, maybe go back a slide and do a bit of clarification for us? Por favor, y lo siento, mi español es muy malo. Lo siento.
Okay, Calvin Jolly, everybody. I have to tell you too that who got scared like me when they heard somebody yelling a little bit ago? Okay. Well, did you know that when I went backstage before I came on, that there were some production folks who were ready to tackle Calvin? Did you know that? He scared them too. We didn't know this was happening, so we're kind of ad-libbing here. So anyway, so Calvin, if I understand your question, because I don't speak Spanish, I think you want me to simplify this, right? What does it mean for the average distributor for us to do all these experiments? And I hope what you get out of this is you don't have to understand proteomics, you don't have to understand size exclusion chromatography. I mean, I would love to be able to talk to you all day about it because it's really what I'm interested in. But for the average customer, the average distributor, what's really important is to know that 4Life cares very, very much about the quality of our products. We care, that's right. The quality of 4Life transfer factor is, it's a special ingredient, right? It's very special. It's something that 4Life has had for 20 years. It's what they built the company on, right? And we take that very seriously. And so it's important that we use these highly sophisticated tools to be able to understand it, to characterize it, to know it, to identify it. Because when we have that knowledge, it's like everything. When you have that knowledge, you can do better things, right? When you have knowledge, all the stuff you're learning right now is giving you knowledge. So when you go out and you want to talk to people about what transfer factor is, you now have that knowledge, right? And that's what we're doing. We're trying to get that knowledge so that we understand from a quality standpoint, at a molecular level, from an identity standpoint, what is this transfer factor? What makes it so special? And what makes it so different? Thank you. And that's what's important, right? It's not so much the proteomics. You don't have to understand that. You don't have to understand size exclusion or amino acid analysis. But you have to understand that we take this so seriously. This is so important. The quality and being able to understand transfer factor and be able to make advancements on transfer factor, make it better, find new forms of transfer factor. All that sort of stuff are things that we work on, and these are all the tools that allow us to do that. So if that's all you get out of my presentation, then I'll be happy. If you want to come and talk at the R&D booth about proteomics, we can talk a lot more about that because we do so much stuff. We're only telling you a little bit about what we have done in the interest of time, but we have so much research, so much quality put into transfer factor that it's unlike anything you're going to get anywhere else out on the market. And that's why we do this. Okay? Does that help you, Calvin? Calvin, did I answer your question? Okay. So I know if I've been able to help Calvin, I've probably been able to help everybody else. So that's something to be proud of. Okay. All right. Should we move on? Okay. Well, how about we summarize? That was a good stopping point for me. So let's summarize it. So 4Life transfer factor is comprised of small peptides and proteins from what? Colostrum and egg, right? It's made by the immune system for the immune system, right? Okay. We also have patented technologies that allow us to extract transfer factors out of colostrum as well as egg yolk, and we utilize state-of-the-art tools like proteomics, size exclusion, to be able to characterize them. And here's the real interesting point, because people ask me, do you know everything about transfer factor? And I say, well, we know a lot, but we don't know everything. Because what we found, what was interesting is some of the proteomic studies we did, while we were able to identify a lot of the peptides and proteins that were in the sample, there were thousands of peptides and proteins that were not identified, that we believe are transfer factors. And we now have the tools to be able to move towards identifying those. In fact, when we did that study, there was thousands of peptides and proteins that wasn't in the database. And when we did what we call a de novo search, which is a fancy term of trying to identify these without any information, there was 35,000 different possibilities that these might be in terms of the amino acids and the peptides and proteins. Okay? So there's still a lot to learn about transfer factor. Okay? Is everybody with me? Everybody on? Okay. All right, now I think we are going to ask a question. So do we have somebody to ask a question? Can we have a raise of hands? Who wants to be a scientist? Who wants to come up on stage and answer science questions? Well, there's not very many hands. Come on! Don't make Calvin come back up here again. I know. Oh, we got somebody. Okay. All right. Good. And these are easy questions in my mind. So let's see how good a job we've done. Okay. And tell me your name. And let's ask you this question. Are you ready? Where are you from first? Colombia. Do we have Colombia? Okay, all right. Looks like we have some from Ecuador. Okay, first question. Oh, and we got another one. All right, so we got 3 people. You can phone a friend. You can get together and figure out what it is, or you can ask the audience. Okay? I'll give you whatever you want to do. Okay, so first question. Let's read it. What process does 4Life use to extract transfer factor from cow colostrum? Is it A, distillation? Is it B, fractionation? That sounds like one. Is it C, ultrafiltration? Is it D, crystallization? Okay, what do you think? This is going to be a contest. We're going to see who gets it right.
I think that answer is C, ultrafiltration.
Okay, all right. You sure about that? Is that your final answer? Okay. How about you? What's your answer?
En español.
E? Fractionation? Want to ask the audience? How about we ask the audience?
Send her back to her seat. You go up to
Trace? Okay, so we've got 2 C's. Ooh, feeling pretty good about that one. Okay, now you look really confident. Are you confident? Okay, what do you think it is?
C.
C. Okay, let's find out. Is it A, distillations, B, fractionation, C, ultrafiltration? That's what everybody thinks. Or is it D, crystallization? Ready? Ultrafiltration. Wow. That's great. That's awesome. Okay, now there's still another question. One more question. Can you do it? Okay. All right. Name one of the 3 ways, and we should actually do this. You name one, you name one, and you name one. One of the 3 ways we characterize transfer factor. Remember how we talked about how we look at its composition, its size, its identity? Okay, one of 3 ways. Okay, what do you think?
Proteomic.
Proteomics. Ooh, that's pretty good, huh? Okay. How about you? You said proteomics, you gotta come up with something different now.
Repítame la pregunta, por favor.
I don't know what that means.
Repeat the question, please.
Let's ask the audience again. Okay. Can somebody help her? Here we got a translator. Okay. The question was, name one of the 3 ways that we characterize transfer factor.
De proceso de colostrum. The process of colostrum, she answered.
No.
The process of colostrum. Okay. Processing of colostrum. Okay. That's not a way we characterize it, but that's okay. There's 3 ways we talked about at the end. Okay. I'm gonna go over. This guy's Googling it, so no, you can't look at your slides. No, you're cheating. This guy, you can't cheat like that. Come on. All right, one of 3 ways. Okay. We already said proteomics. That's the toughest one in my mind, right? Who's heard of proteomics before this? Probably not very many people. So that one's off the board, right? So now you got the other ones. What do you think?
Size exclusion,
You have to say it correctly.
size exclusion, chromatography.
Whoa! We got it! That's awesome! Okay, she's ready.
Tamaño.
You're saying size exclusion chromatography also? This guy, let me tell you, you come up here and you act smart, and you're just sitting here looking at your phone. You're cheating. All right, so what do we got? We got proteomics, size exclusion chromatography, and
Ácido composición.
that's right! Amino acid composition! Can you believe it? That's awesome. So let's check it. Let's make sure. Size exclusion chromatography, proteomics, amino acid analysis. That's good. Thank you so much. That's great. Thank you. Thank you. Good job. Thank you so much. And